Okay, now simple machines. And simple machines are devices that are used to multiply forces or change the direction of forces. So examples of a simple machine are things like a ramp, believe it or not, is a simple machine. A lever, we talked a lot about those. A wedge is a simple machine. A screw is a simple machine. That's basically a ramp wrapped around a nail. And then, of course, a pulley is a simple machine. And we talked most about levers. But let's do a ramp problem first. And let's say that we have a truck here, a moving truck, and we've got a fridge right here that we've got to get up onto the back of this truck. Okay? And let's say the fridge has a mass of 100 kilograms, and we want to lift it up onto the truck. All right? Well, how do we do that? Well, we've got to apply a certain force, and over a certain amount of distance, we've got to say how high this truck is off the ground, and let's say it's 1 meter up. All right, 1 meter, and we've got to figure out how to get that truck on there. How much force is that going to take? Well, first we say, what's the weight of the refrigerator? What is the weight of this refrigerator? And of course, the weight is the force that we would need to apply to bring it up, to lift it up onto the back of the truck. And force is mass, weight is mass times gravity, which is 100 kilograms times 10 meters per second squared, which we'll say is 1,000 newtons. Okay, so that's 1,000 newtons that we have to lift 1 meter. So that means the amount of work that we're going to do, the work is force times distance. Okay, force times distance is the weight of the refrigerator, that's the force, times the distance we have to lift it, 1 meter. So 1,000 times 1 equals 1,000 Newton meters, which we call joules. All right, so once we get this refrigerator up there on the back of this truck, we will have done 1,000 joules of work. And of course, according to the work energy theorem, where the amount of work you do equals the change in the energy of that object, if this refrigerator is sitting on the ground here, it has 0 potential energy. But if you do 1,000 joules of work to lift it up onto something else, then you have changed that energy, potential energy, by 1,000 joules. So we now have 1,000 joules of potential energy. Okay, but let's say that you are not strong enough to lift 1,000, to do 1,000 joules of work. You can only exert a force of 500 newtons. All right, let's say that that's as much force as you can muster. In which case, we'll have to do something else. We'll have to put a ramp in the back here. Okay, so what question are we getting at? Well, you're going to push this thing up a ramp, which is a machine that's going to help you use less force, but you're going to have to do apply that force over a longer distance in order to get it up into the back of the truck. So here's you're going to push this refrigerator up this ramp. And how long does the ramp need to be? That's the question we're really getting at. So, well, how do we do that? If you are only able to apply a force, work equals a force of 500 newtons. All right, that's as much as you can use or push with. That times some distance is going to equal the amount of work that needs to be done to get this refrigerator up onto the truck. And that amount is 1,000 joules. That's how much work needs to be done. We already calculated that. All right, 1,000 joules of work is what's needed. So here we have an equation. You are able to supply 500 newtons of force. 1,000 joules of work needs to be done. So we're going to divide both sides by 500, and we end up with the distance, meaning the length of this ramp, the distance from here to here, that's D, is going to be 1,000 joules divided by 500 newtons, okay? And that means it's going to be 2 meters long, all right? 2 meters long is how long that ramp would need to be in order for you to push that refrigerator up the ramp in order to get it on the back of the truck, if you were only able to supply 500 newtons of force. What if you were only able to supply 300 newtons of force? Well, you'd still have to do 1,000 joules of work, because no one can change that. But if you're only able to do 300 newtons of force, or apply 300 newtons of force, then we would say 1,000 equals 300d, and d would equal 1,000 over 300, which is 3.3 meters long. So that means the ramp would need to be even longer, 3.3 meters long. All right, so the longer the ramp, the less force you need, but the amount of work that you do is the same, okay?